Okay, so let's take a look at what we did earlier today. So remember that the rest of the ones that were left is what you have for homework. So we worked on the first two together, and I showed you what the expectations were on those. And then we came across and we worked on this problem here where we were saying that you had to look at just the data itself and then read the problem. And we labeled the spinner 1, 2, 3, 4 on one of the spinners, and the second spinner was 1, 2, 3, 4. And it says that it'll land on 2 on one spinner, 4 on another, and that we could pick out that on one time it could be the 2, on the other spinner it can be a 4, and so we know that we can have a 2, 4. But we also know that on that first spinner, on spinner 1, we can also roll or spin a 4, and then on that spinner 2, we can also spin and land on 2. So then the other possibility would be 4, 2. And then you looked here on your data and which one showed a 2, 4 or a 4, 2. We have the total amount at 20 times. So I can see that for my fraction, and I do want you to write out that word fraction to remind you that with probability we have fractions. Same thing with ratios and proportions. Everything is a fraction. And then you're going to match. I'm looking down the first column. I can see here it's a 4, 2. Coming down to the next one, there's nothing there. On the third column, nothing. But on the fourth column, on the first row, I have a 2, 4, and then I have a 4, 2, and on the last column, I have a 2, 4. So out of all of this experimental probability or data, I can have 1, 2, 3, 4. So 4 out of 20. And then we talked about how I don't see 4 20ths here, but I know because they're both even numbers, I can simplify this at being a 2, 10. It's still an even, so now it can be 1, 5. And I can show that this is my correct answer. We also worked on this one here, and this is going back to comparing what we did last week. So I'm going to use my answer choices here, one by one, and compare it to the data to see if this is true or false. I discussed in most of the classes that because you're going to be working on a computer and you'll have that A, B, C, D choice, right, or on the side, you can just simply label it yourself, A, B, C, D, on your paper, and then you can write true or false on it. So for instance, Bob spends most of his time on homework. Well, I can see that, or spends the most time on homework, that is true. That's a true statement. So I can just put T for true and then move on. Next, I'm going to read this next statement. Alice spends more time on homework than Carol. Well, Alice has 6 hours and Carol has 8. That's false. Carol has 2 more hours, 2 plus hours than Alice. So then you can do it that way and then cross that out. So then when you're going to go put that into the computer to click on your answers, you can confirm what you came up with while you read over here. So that's another great strategy to help your brain sort out leaving the computer screen onto paper, from paper back onto the computer screen. Carol spends less time on homework than Bob. I'm going to Carol, and that was at 8 hours. Bob was at 10 hours. That's a true statement, right? Carol does spend less time on homework than Bob. Yeah, she spends 2 hours less time. So that's also a true statement. And then I'm going to also circle that A because we said that was true. And looking at this next one, Bob and Carol spend the same amount of time on homework. Well, we can obviously see based on our data that that's not true. Remember, Bob has 10 hours, and it's not equal to 8 for Carol. So that's not a true statement. And so that makes it false. And here I can cross out, cross out. So I can do this because it's on paper. This side would be what I do with the computer access. And so I was able to find my 2 answers. So this is the type of work that I want you to start showing, or make sure that you continue. You were doing this one as well, so you're going to find the comparison for students. And so I don't need to go through that one with you. It's going to be the same with the one that we just did. It'll be the same thing with here. Here they surveyed 40 people about their preferred type of exercise. And you have running, the number of people is 12. So the number of people that like cycling was 10. The number of people that like swimming was 8. Number of people that liked yoga is 6. And the number of people for weightlifting was 4. You're going to read these and see which comparisons are correct. All right, turning the page. This will do the same thing, but because I was doing this during spring break, right, I noticed a typo that when I was bringing it forward. And so you're going to cross out this part. So your sentence is actually going to start with Jake and Lily combined scored more goals. Goals than Mark. And there's that part right there. So I'm going to cross this part out here. So that doesn't exist right there, and this is the new sentence you have. Jack and Lily combined scored more goals than Mark. And then showing your work, or showing your work you want to confirm what is your answer choice and why you chose that and why the others don't work. All right, so this is one that you will see on Wednesday's test. Again, you have your end of the unit test. This is one that we've already been working on last week, and I wanted to review this. The results of a survey of 30 students are shown. Okay, so you have 12 students walk to the park, 15 students ride their bikes, and 3 students will be driven by their parents. Okay, so based on the survey results, select the 2 that are the best prediction of how 100 students will travel to the park. Well, I've taken out of that 120 students, I've already surveyed 30 of those. So now I can simplify this fraction, right? So I have to create a fraction. Again, this one isn't where the total amount is on the bottom, because the number that we surveyed is my denominator. Total number of students surveyed from the 120. So now I know that's going to create 4 equal groups of 30. So I'm going to bring down here, I have number of students that are going to walk are 12. But if I were to survey all those 120 students, remember I'm going to have 4 groups of 30. So I'm going to multiply that by 4. 12 times 4 is 48, so it'll be 48 students. The number of students that will ride their bikes, so I'm going to put bikes. It's going to be 15 times the 4 equals 60. I'm going to just put students. And on here, I'm going to put just STS for students. The next one is going to be 3 students will be driven by their parents. So I'm just going to put parents or drive or driven. It's up to you. And again, I'm multiplying it by that 4 groups that I have, 4 groups of that 30, so it becomes 12 students. Now, based on my new data, my information, it's not really data, it's not really new, but it is consistent to if we took 4 groups of those 30 in each group and interviewed them, this is a probability of what would happen, so our predictions. There are 48 students who will walk to the park. So here I put walk, 48, so again, this would be true. I'm going to put a T to the side. And so that's a possibility, right? So I'm going to circle this one. There are 90 students who will walk to the park or ride their bikes. So here I have walk was 48, and I'm just going to write walk on top. It is super important to label your numbers. Leaving numbers unlabeled can create the confusion, because then you don't know what you use that number for if you didn't have your them labeled. You want to keep showing your work as clean and neat as possible. And ride their bikes. Bikes is 60. So are there 90 students? No, I can see that 48 plus 60 is 108 students. So this makes it false. So I can cross this out. Moving to the next one, there are 36 more. So immediately when it's like, oh wow, 36 more who ride their bikes than, because we're comparing, will walk to the park. So I know I'm going to have to subtract. So here I have the number that rides their bikes is 60. So I'm going to have bikes minus walking to the park, it's 48. Looking at here, can I see that that's going to give me a difference of 36? Is that a true statement? Absolutely not. Just looking at here, I can already see that it's greater, because 40 plus 30 is 70. Then I'm going to add another group of 10. That's 80, so it makes it 84, so it's greater than 60. So sometimes it's always good that you can work backwards. You don't always have to keep subtracting, but you can add to see if you can get to 60. If you're wanting to subtract it, you may. Remember, you're going to be regrouping. That becomes a 5. And here I have 2 and then 1. So it's only going to be a difference of 12, not 36 students. So this is false. Remember, you can stop this video at any time, replay it, so that you can write the information down and have a better understanding. There are 60 students who would walk to the park or be driven by their parents. So I have the walk, 48 students that want to walk, and it says driven by their parents. So I can already see I have 12 that will be driven. And that does equal to 60 students. So we can see that there is another positive answer. And it did ask me to select 2 that best predict on how the 120 students will travel to the park. So I was able to do that. All right, you're going to do the same concept with this part right here. You have the results of 40 students are shown. 18 students travel to the zoo by car. 12 students will take a bus, and 10 students will walk. Based on the survey, which of these best predictions of how 160 students will travel to the zoo? Again, only 40 were surveyed. So I'm going to set this up. I will need to create my fraction. I have a total of 120 students. Out of those students, I surveyed 40. So 40 goes into 120 30 times. So I'm going to be having not 30. I don't even know why. My brain's like, wait, that's not right. I'm going to just scratch the whole thing. It's 3. Okay, so I know that there's going to be 3 groups of 40 students in each group that I would need to interview. You're going to follow the same concept. Make sure that you pull out your information where you have your 18 travel by car, you have 12 that travel by bus, and you have 10 that walk. You're going to multiply each one by 3. 18 times 3, 3 times 8 is 24. Regroup the 2, 3, 4, 5. 12 times 3 is 36, and 10 times 3 is equal to 30. And now you're going to take this new data and apply it to the data given here. So we're going to be comparing, is this data going to match, or what makes this a true statement. So we're looking for the best prediction. And you'll do the same thing with this bottom one. All right, you're going to have this one ready for tomorrow to turn in. Again, this is what we did in class, so if you did not do that, you need to go back and get that part done. Okay, make sure that you're labeling where you have the 5 red marbles, and I know I didn't read it. So you have a box of 5 red, 3 green, and 2 blue. Remember, you were adding that up. You got 10, and so you have your fraction. What is the probability of selecting a red or a blue marker? So red and blue. So here I'm going to have 5 red and 2 blue. So 5 plus 2 equals 7. So now I'm able to find the probability that it would be about 7 out of 10. And it's B. Okay, and you'll do the same thing here. This is what we did in class as well. We did that one together, so you'll need to show your work to get credit. We did these 2 in class. This one, I brought that one in. Well, no, this was on Lead Forward. It was our star quest, one of our star questions. And then you have this one here to work on. Okay, again, this is due on Tuesday. Yes, it is a grade. And at 3/17 of 25. All right, there you go. Have a great evening. Bye.